All right, this is for Algebra 3-4, and what this topic is about today is writing and graphing linear equations in standard form and being able to graph them using the x and y intercepts. So we're going to talk about what standard form is. A standard form of an equation looks like this, to where ax plus by equals c, which that means a, b, and c are integers. Okay, so a, b, and c are integers. Typically, you won't have fractions or decimals. We can clear those out if possible. But what this means is that the x and y are on the same side. So for an example, we might have like negative 2x plus, hold on, I lost my example. Negative 2x plus 6y equals 30. Okay, so that's an example of in standard form. Okay, we can actually graph this equation because remember, when you have one equation with two variables, with two different variables, you're going to have multiple options to make this statement true. Okay, the one way we graphed last week was slope-intercept form. This time we can graph using the x and y intercepts. And what the x-intercept is, the intercept, remember how it crosses paths? So the x-intercept is where it crosses the x-axis. The y-intercept is where it crosses the y-axis. Now, in order to have a point on the x-intercept or the x-axis, the y value must be 0. And in order to be on the y-axis, the x value must be 0. So what we're going to do is we're going to find the x and y intercept. And in order to find the x-intercept, meaning where the line crosses the x-axis, you need to plug in 0 for y, plug in 0 for the y value, okay, for the y value, and then solve for x. And then when you're finished, you're going to write your ordered pair. Typically, you're going to write it with a number and then 0. So write as 0, number and then 0. So your number is your x-intercept, how far over, left or right you're going, and the y, that you're not going up or down at all. So that's why it's on the x-axis. Now finding the y-intercept, you're going to plug in 0 for x and then solve for y. And then you're going to write that as 0 and then your number. Okay, so what we're doing is we're just another way to graph the equation, to graph the solutions to an equation. Now that line is not this one, so don't think that those two are related. Okay, so we're going to look at these examples. We're just going to find the x and y intercepts. We're not going to graph at all on these two, but we're going to find the x and y intercepts. Again, to find the x-intercept, you need to make the y value 0. So you're going to have 2x minus 3 times 0 equals 18. 3 times 0, negative 3 times 0 is 0, so you're just going to have 2x equals 18. So the x equals 9, the x-intercept. So you're going to write the ordered pair 9, 0. Now the y-intercept, you're going to make the x 0. And so that's 0, so you're going to have negative 3y equals 18. And y is going to equal negative 6. So the y-intercept is going to be 0, negative 6. Okay, so you have x-intercept and the y-intercept. Then if I wanted to graph it, I could graph it. All right, so now here's another equation. 4x minus y equals 1. And we want to find the x-intercept. That means the y value is 0. And minus 0, so that's going to be just 4x equals 1. Divide by 4. Divide by 4. The x-intercept is going to be 1/4. So it's going to be 1/4. 0 is our ordered pair that we're going to plot. The y-intercept, that means the x has to be 0. So that's 0, so it's a negative y equals 1. And y is going to equal a negative 1. Remember, you have to divide by negative 1. So the y-intercept is negative 1. That means it's going to be 0, negative 1 is our ordered pair. So x and y intercepts are actually really neat to use. And if you notice, like this one was a fraction, that's okay. But that's okay to graph. It won't be real hard to graph. So a lot of times the x and y intercepts is a good idea to use if your equation's already in standard form. Okay, so now let's do a few more. We're going to find the x and y intercept. So again, here's our equation. And we're going to go down here first. You can't graph right away. Let's find our x and y-intercepts first. Again, the x-intercept. In order to find the x-intercept, the y value must be 0. So you have negative 3x plus 0 equals 6. Negative 3x equals 6. And x is going to equal negative 2. So the ordered pair is going to be negative 2, 0. Okay. Then the y-intercept, the x value is 0. Because that's what's going to be on the y-axis. If the x is 0, that's how you're going to graph the y-intercept. Negative 3 times 0 is 0. So you just have y equals 6. So we have 0, 6 as your ordered pairs. So here are the two ordered pairs that we're going to plot. We're going to have negative 2, 0. Whoa, wrong way, sorry. 1, 2. Negative 2, 0. And 0, 6. 1, 2, 3, 4, 5, 6. Then take some tape, a straight edge. I don't know, I'm just going to use this paper. I lost my other straight edge. And then you're just going to go through the graph. There we go. Go through the graph and your arrows. Now notice our domain and range. We could pick any number for x. Like we're going to continue moving on. So this is going to be all real numbers. And our range is going to be all real numbers. Okay, meaning you can put any number, since you have arrows here, you have any number going in for x and any number going in for y. Okay, so let's try this one. Negative 2x minus 5y equals 10. The x-intercept, in order to be in the x-axis, the y value must be 0. So negative 2x minus 5 times 0 equals 10. Negative 2x equals 10. X is going to equal negative 5. So it's going to be negative 5, 0. So our x is negative 5 and our y value is 0. The y-intercept, you want x to be 0. That's going to be 0. Negative 2 times 0 is 0. So you're just left with negative 5y equals 10. Divide by negative 5, and you get negative 2. So your ordered pair is going to be 0, negative 2. So negative 5, 0, and 0, negative 2. So negative 5, 0, negative 5, 0. It's going to be over here. 1, 2, 3, 4, 5. I hope that's right. 0, negative 2, 1, 2. And then a straight edge. I can't. Oh, I could. You could use your paper possibly. Nah, that doesn't work. I need to find my straight edge. Okay. Then just connect it. Right? So this is like graphing in slope-intercept form. Well, not like slope-intercept form, but you're finding the same solutions as if this was written in slope-intercept form, which that's going to be next, is how we're going to take the standard form to change the slope-intercept form. So just another way you can graph the solutions to that equation. So all of these ordered pairs on here are solutions to that equation. The domain and range, again, are going to be all real numbers. All right, so I want you to go ahead and try these two on your own. I'm going to go ahead and you can pause the video and do this. And then what I'm going to do is I'm going to go ahead and write the solutions here, and then you can look at the solutions, okay? So pause it, do this yourself. Pause it and do it yourself. Just teasing. Okay, welcome back. So here are the solutions to these two, because I already did this with class. This is why I'm doing this. Let's see here, 0, 3. So those are the x and y intercepts, but make sure you do it. And if you have a problem and like, hey, I am not getting that, or if I made a mistake, let me know. I don't know if I did, but let me know. But otherwise, you do that, and that's how you graph in and doing your x and y intercepts.